Okay, good morning, good afternoon, good evening from anywhere you might be joining us from. I believe you can all hear me. If you can hear me, please just give like a thumbs up. All right. So once again, good morning, good afternoon, good evening from anywhere you might be joining us from. My name is Oladapo Babalola. I'm the founder of DevOps as a Service Nigeria, also known as daas.ng. So daas.ng is spelled daas.ng. So for those who are just hearing about DevOps as a Service Nigeria for the very first time, so daas.ng is a free mentorship boot camp founded 3 years ago to train and mentor the next generation cloud and DevOps engineers, with the skills needed to boost their career. So, for those that might be wondering, why are we doing this? Like, why are we training and mentoring the next generation DevOps engineers for free? Well, would say that it's our own way of giving back to the Nigerian community, right? And so we've been having boot camps, we've been having webinars for the past 3 years, and so we commenced the boot camp for this year a few weeks ago, right? And so today we are shifting gear a bit. Today we're not talking about Kubernetes, we're not talking about cloud, we're not talking about all of those cool stuffs, but today we are talking about artificial intelligence. Because right now, I mean, that's the hot topic that everyone has been talking about. Every meeting you go to, every conferences that you attend. I mean, we just finished KubeCon just few days ago, and everybody, we're just literally talking about AI, how to infuse artificial intelligence into the open source tools that we have today, right? So every conferences you attend, every meetings you attend, even at work, management would always want to talk about how they can integrate AI to make the processes better. So you would find discussions right now about AI, right? So, but beyond the hype of AI, beyond artificial intelligence that we know today, beyond machine learning that we know today, we we are going to be taking a bold step to go behind the curtain to sort of understand what really happens behind the scenes. Because when you mention AI, the first thing that comes to mind is ChatGPT. Let me just go to ChatGPT and type whatever it is I want to type to get the answers I need from the machine itself. But beyond generative AI, we want to go behind the scenes to understand what really happens, like what powers AI itself, like what powers the machine learning that we have today. Right now, many people would just talk about what you can see, that's the front end, but you don't get to find so many people talking about the back end itself. So today, we're going to be dissecting what models are, how they are built, how does training happen, what is even the kind of infrastructure that powers all of those, moving parts itself, right? Talking about inference, talking about GPUs and all. So, to be honest, we have a lot to learn today, and I'm so excited about our guest speaker. And at the right time, we are going to properly introduce him. So, to take us further, I would not want to waste much of our time. So to take us further, I would want to, hand over to the moderator for today, Oluwaseun Oyetoyinbo, who is also the co-founder at DevOps as a Service Nigeria. Right. So over to you, Sheun.
All right, thank you. Good morning, good afternoon, and good evening, everyone from wherever part of the world that you are joining from this afternoon. Like Dr. has mentioned, thank you for that wonderful introduction to what we're doing today. Why do we have this webinar? We want to go away from, I won't say going away from the technical because there will still be a lot of technical discussion to talk about, but we don't want to talk about Kubernetes. We don't want to talk about cloud. We want to look at something that is transforming the world of the whole world, not just the world of IT. It's often said that technology, information technology, is changing the way we work, it's changing how we live, how we play. Those days while we're growing up, we play outside. But today you play online, you play games online, you play with everybody, people from different parts of the world, without even being within your vicinity. As far as Europe, as far as America, you can play with people. And that is thanks to the power of technology. So this afternoon, I want to look at what is really behind this AI. A lot of people have been talking about artificial intelligence that was mentioned. Artificial intelligence is beyond using Copilot chat. It's beyond using Gemini. It's beyond using ChatGPT. There are things behind. And as usual of our foundation, we don't dwell too much on tools. We don't dwell too much on being a consumer. We want to go beyond those consuming. We want you to understand, what is the engine that is driving the work that you do? And that's the reason why we have this webinar this afternoon. And a lot of people have been wondering, what is going to be, what is really behind this curtain? When we had a deep dive on Kubernetes, a lot of people are so used to spin a container. I know there's a worker node, there's a control plane, and the likes. But we went further to really understand what makes Kubernetes Kubernetes. And this afternoon, that's what we want to do also. We want to take the same clue to understand what makes artificial intelligence, what is behind it. And the reason is that when you understand what is behind it, it helps your view of the work you do. It helps you to really position yourself along the chain. Dangote brought something different. He went beyond being a consumer of oil and decided to set up a refinery. And that is because the man understands what is what behind the curtain. He knows how to drive the market. He wants to influence the market. He wants to really determine what he wants to be one of the players that will determine how much should oil be sold in Nigeria. And he's achieving that. And so this afternoon, if you understand what is behind the curtain of AI, you can contribute meaningfully. You can make some influence to what we see. And some things, I had some engagement recently, two, three engagement recently that really will also help our discussion this afternoon. And one was a friend of mine, we were chatting yesterday, and he said he has built a boat that is, and what is that boat doing, the boat doing for him? He said there are things that his compliance people will not do for him in terms of how compliant he is, in terms of checking access control. There are controls that should be in place as an AI engineer, and that he decided to build a bot that will do all those checks for him, that will tell him when his consumption is going beyond the budget. And that is because that man, the guy understands what is behind AI. And recently, I saw on news where Google was bothered with a decline in their revenue from their global search. And I think in 2025 Q4, they had a deep, there was a drop to about 89% range for their global search. And what that means is that people are no longer using Google search for making searches well anymore. People are gradually changing. What people now do these days is they want to check, go to the likes of Copilot, go to the likes of ChatGPT. And interestingly, you don't have to, and the way it brings up the result for you is different from the way you consume it if you're using a Google Chrome. And that is because of somebody is understanding what is behind the scene. And this afternoon, we brought in somebody that is quite experienced with a number of years, over 70 years of experience in artificial intelligence, just to help us see what is behind this AI. The modeling part of it, the GPUs, and a lot of things. A lot of time, of recent in the stock market, we started talking about how the capital of um what's it called? This chip producers is beginning to grow because of these are part of the things that are happening behind. These are part of the drivers, the engines behind artificial intelligence. And of recent also, I saw a demo of Kali Linus, and they were trying to demonstrate the capabilities and the features that the recent version, the 2025 version has. And guess what? From prompt, you can do a vulnerability scan without you going to any tool. All you just need to do is just write, I want you to carry out a vulnerability scan on my application. Let's say, for instance, I'm using Microsoft PowerPoint. I want you to do a vulnerability scan on Microsoft PowerPoint. From that prompt, and this happened using the Gemini CLI. From that prompt, from the Gemini CLI prompt, it's going to spin all the required tools. It's going to come up with all the required commands, give you the results, let you know where the vulnerabilities are and what you should do to remediate it. And that is changing the way you do. So just imagine 2, 3 years from now, you have a board built that will be managing your infrastructure for you, that is giving you insight, that is telling you what to do, is checking and so the beauty about understanding what is running behind that curtain is that you know the job and you know why when there are issues, when you see abnormalities around, you can quickly figure it out and take it out. And because of time, and something interesting, I was watching one of the engagement of our speaker this afternoon, and he made mention of something. He said people often said that AI will replace um, people, and he said no, that is not the situation. That what will happen is that people that has knowledge of AI, people with the knowledge of AI will replace those without the knowledge of AI. So AI has not come to replace anyone. Rather, if you have the knowledge of AI, you'll be replacing those that don't have that knowledge. And so we have to come to, we are in a world whereby AI begin to partner with people, and how much of knowledge you have around the workings will really help in you delivering value as a Kubernetes engineer, as a DevOps engineer to the world and the global space all around. And so, and that is just an overview of what we're expecting this afternoon. The doctor is already set to take us through, to see a lot of things behind the curtain, to help inform our view and also inspire us towards ensuring that you're not just being an expert, you're not just acquiring the technical knowledge, but you're able to see how well you position yourself and make impact in the technology space. Thank you, everyone. And so I'll go ahead to introduce our speaker for today. Like we all mentioned, like earlier mentioned, this is Dr. Nnanna Orieke. Dr. Nnanna Orieke is the lead architect, data analytics and AI. He works with Microsoft. He's a man with many caps. And saying that means that he's an artificial intelligence expert, a researcher, and a software developer. Imagine when you have a software developer that is also a researcher. You can imagine the quality of product that will turn out. And so um, he's an highly accomplished IT professional with 17 years of experience in artificial intelligence, research, software development. His career goal is to leverage technology to benefit humanity, promoting diversity, inclusion, and providing individuals and organizations with a platform for innovation and transformation. I'm so sure it's not a surprise to me. Looking at how the doctor stumbled into artificial intelligence, and I was listening to one of his talk, one of his engagement, and he said it was because of he wanted to solve a problem. He wanted to see how we can help people suffering from diabetes without having to use a tool. I mean, you want AI to be able to tell, I mean, to check the level of sugar in the bloodstream, and you can tell at what point in time if it's normal or is abnormal, without, I mean, going through means or maybe medical means of using medical tool to do all those check. And that was how he got stumbled into AI. And today, he has a PhD in artificial intelligence. As an architect for data analytics and AI at Microsoft, he's responsible for developing the vision, strategy, business, technical requirements, end-to-end delivery of data and AI-based solutions to grow Microsoft customers' businesses. With 17 years of experience, he has worked with big data technologies. Currently, he holds certifications in IoT, data science, AI, data management, and analytics. Like I earlier mentioned, he has a PhD in artificial intelligence from the University of Lagos. He has MSc in system engineering, and he has the Bachelor of Engineering degree in electrical electronics engineering from the Federal University of Technology, Futo, Owerri, where he had graduated with the distinction as the best graduating student for his set. Dr. Orieke is a member of professional organizations, including Nigerian Society of Engineers, Nigerian Institute of Electrical Electronics Engineers, and Institute of Electrical Electronics Engineer. He's married to barrister Nnanna Orieke and he's a proud father of two daughters, Jane and Summer. Join me to welcome Doctor this afternoon as he take us behind the curtain and do justice to the topic. Please just put your hands together for him. Just give him an emoji of clap. Doctor, over to you, sir.
Okay. Hi, everyone. Thank you for having me in your boot camp. I'm very well honored to be part of this, and thank you very much, Sharon and Dabo, for this initiative. It's really good, especially in our client, to have folks who are contributing to the betterment of Nigeria and Africa at large, right? So I'm really, really proud of what you're doing. And thank you very much, Sharon. I think you've researched me very well. As you were speaking, I was just wondering, where did I say all these things? I can't even remember. I can't even remember giving away some of my personal inspirations and the rest online. So I think everything shared online is out there, but it's glad to know that folks are also researching and reading about me. So today I'm going to really talk about, let me just go ahead and share my screen. I know we don't have too much time left. Do let me know when you see my screen. I'm sharing it right now. Just let me know when you see it.
Yes, we can see
We
it.
can see it.
Okay. So I'll just go into the meat of the discussion, an overview of what we're going to talk about. I heard a whole lot about books during the introduction, talking about using ChatGPT or using Copilot, and folks talking about AI in that mindset, with that mindset of typing things online and getting intelligent responses. But I think I would like to take it back to really how AI started, and because it will give you clarity on what is really behind the curtain, right? And also empower you on how you can take this even beyond this discussion. Because I know, obviously, some of you might also be interested in becoming AI engineers and data scientists, as the case may be. I'm not trying to steal some of your talents and share and that, but it would be good to have more people in the AI space. So hopefully, I'll be able to win some of the mind share from the DevOps community. I'll go into a brief history of AI, and I really want you to pay attention to some of the details I'm going to share in this brief history of AI. Because it kind of seems like AI started yesterday or 2021 when OpenAI released the GPT-3, right? But we're going to really talk about the history so that you know that I don't think any of us here is as old as AI is. Right? So it's really, really, really older than every one of us here. So it would be nice for us to know how it started and where it is going. The very first mention of the word AI was in 1956, right? It was actually created in 1955, but it was publicly declared in 1956 by John McCarthy. But this is like even before the creation of our lovely nation, Nigeria, right? That AI had actually been there. In the 50s, you had a lot of work which was being done by scientists to make to make computers reason like human beings, right? And what were they trying to do then? Because if you remember, because you guys are DevOps engineers and you know a lot about infrastructure, so you could also have this view of what kind of computers we had then, right, in the 50s compared to what we have today. And so what the scientists or the researchers then were doing was to do more of what you call symbolic computing, right? a way of representing the knowledge of human beings with symbols. Think of it like you go to school, right? And let me not use school, let me kind of use the medical space. A patient comes to a doctor and says whatever symptoms he or she has, and then the doctor then makes a diagnosis of what is wrong with this patient. And the doctor is making those diagnoses with the knowledge the doctor got from the medical school, and is able to say, go take XYZ, and then you will be better. Or maybe I don't have enough information, go run this test, and then we'll go do and then we can then decipher what is wrong with you. Scientists then say, how can we kind of represent this expert knowledge, right? Because there weren't too many experts then. So how can we represent this expert knowledge in such a way that we can actually scale the number of doctors we have or the number of researchers we have, right? And then do more. And so they went into symbolic reasoning. And what were they doing there? To say, they will say, if your temperature is XYZ, and your weight is whatever other number, then you're most likely suffering from malaria. And so they documented those, and they became more like symbolic representation of the human knowledge. And that was what they were using to kind of create things. So you will see solutions like expert systems trying to predict or diagnose what is wrong with patients, leveraging documented symbolic knowledge of human beings. You could actually call it rules, right? And if you're DevOps engineers, and I believe most of you are software developers, you actually use primarily rules to do things, right? If X, then Y, right? Or if X plus Y, then if a condition, then something then gets to happen. But imagine a scenario where you're representing that same set of things, right, about a human activity. That actually becomes artificial intelligence. So this was really the beginning of artificial intelligence, trying to make computers do things the way human beings behave. And it could be rule-based. So if you're writing any rule today to do what human beings do, you've actually created artificial intelligence. It is not just that you're using ChatGPT and the rest. You've created artificial intelligence if you're doing that. Symbolic computing was super, super difficult because the computers were not very strong. It was difficult to program, and for you to extract human knowledge was not an easy thing. So imagine going to a doctor to say, how do you make this decision? And the doctor is trying to explain to you, and you're documenting it. It was super difficult. So scientists in the early 70s to 80s started a sub-symbolic compute way of performing of extracting knowledge, which is a lovely way of saying statistics and mathematics, right? To say, rather than us creating this rule base of how people get to do their work, let us have a mathematical way of representing knowledge, right? And it was a boost then, right? Around this period, 1997 was a very, very special period. That was when IBM launched the Deep Blue computer, right? It was a massive machine. It was called a supercomputer then. And it was used to beat the chess champion, right? More like brute force search. So if I believe some of you are mathematics students. So when you do brute force search, you're kind of looking at all possible scenarios of solving a problem. So you look at your chessboard and see the all possible scenarios of solving that chessboard of what position should you put. So this computer was doing about 200 million position investigation per second. So could you imagine how massive the compute power was at this point, right? And so scientists then found a way to say, see, we have massive machines that can actually reason over data. Rather than us going towards extracting knowledge from these experts, why don't we get data and let the computer extract the knowledge by itself? So rather than me going to meet the doctor to say, tell me the reasoning behind your diagnosis and your recommendation, what I'm going to do is I will get all the record about these patients, your temperature, your weight, the sickness the doctor recommended or the doctor diagnosed, and the prescription. I'll get a lot of this information and I'll give it to a machine, a computer, to say, discover the pattern. And it turned out that this pattern kind of correlated to the knowledge, right? Because in between the data points were a representation of the knowledge of this expert to say if this and this are the case, then you are then going to predict why. So that was the beginning of a whole lot of work around machine learning, which is nothing but letting the computer discover the rules by looking at the data. Unlike what we were doing before, which is extract the rules, this one, you're then letting the computer discover the rules themselves. And this had massive adoption. People in the bank today, if you're watching maybe Netflix or any of these solutions, they are all using machine learning, right? All they're doing is basically, I want to know who is going to default, on this loan, what movie should I recommend to you, right? All these things are using machine learning. Are they relevant today? Yes, like a whole lot of people are doing this as AI, machine learning. The key thing that you should note about this is what you're doing, if in math, you have this way of representing things. You always have maybe y is equal to ns plus c. That's the equation of a straight line, right? If you know that part. The y is what you call your dependent variable, right? And the x is what you call your independent variable. We always assume that this independent variable is something that we cannot create ourselves. So I want to predict who will default on loan, which is a y, and I'm saying that it is dependent on how much you have in your account, how old you are, and what level of qualification do you have. Those are independent variables. And I'm saying that would help me determine whether you will default on a loan or not. This is what machine learning is doing. Looking at the independent variable and predicting what the dependent variable is. And it is working very well for most people. In machine learning, you use a lot of algorithms for this. Just like your straight line algorithm that you can use. But there's a particular algorithm that you use in machine learning that is called neural network. It is a mini representation of the human brain. You can use it for machine learning. But in 2012, you had the AlexNet, which is a kind of neural network, big, deep neural network. So neural network, you can only have one, but you can have one, but you can have multiples of it stacked up in a very deep layer, which is what you call deep neural network. This kind of changed the way AI works. We went out from just predicting whether somebody will churn or not churn or recommending product to seeing whether we can see. Like I'm seeing a picture and I say, well, this is Nnanna. This other picture is not Nnanna. You're using your mobile phone today and you can actually log into your mobile phone with the image with your face. That is deep learning. That is convolutional neural network. All you're doing is machine learning, right? Which is learning from data alone, but you're using a particular model called neural network. So this deep learning is a subset of machine learning, only implemented using neural network. And most of the things that you see today in the image analytics space or voice translation and speech recognition and things of that nature, they're coming from deep learning. But remember, you're only still predicting the dependent variable using the independent variable. In 2021, you then have a subset of this deep neural network, which is I'm still using my neural network. It is deep, but I'm using a smaller form, a particular form of this neural network called transformer models. And what this helped us, this was revolutionary. And so what you're seeing now, actually came up around 2021. It was first introduced in 2017, right? right? By one pep I called attention is all you need. But this kind of change a whole lot of things. One point I will make here is rather than predicting the independent variable, I actually help you create rather than predicting the dependent variable, generative AI helps you create the independent variable. Let me kind of make this sink. Imagine you're in a bank and you want to predict who is going to churn or who is going to default on a loan. You're going to use all their activities, transaction activities, or their demographic information to predict that. Well, imagine a scenario in generative AI where you are actually creating that person. You're saying, this person A is going to default on a loan, but this person has never has not been created. It's new. I'm predicting the independent variable to say this person I'm creating is going to default on the loan. And this transformed everything. And this is why we're seeing this revolution. We are creating things that don't exist, things that are new, that are unique, right? Because we've trained the model to understand how to write, how to create images new that have not existed before. And so this is where we are right now in the history of AI. What are the typical things that you see when you're creating AI? And this is general machine learning. So you'll notice that everything we're talking about now is just a subset of machine learning. So that pattern is still is the same. You are always going to start from, I'm going to talk about the classical one. You're going to start from the data. I explain machine learning to be learning from data, which means you're going to have data as the first thing. The data you're going to have is going to be your training data, right? And one thing to note about this training data is that before you use it for training, it must be numeric because it is computer you're using, and it basically understands numbers. It doesn't understand text. It doesn't understand anything. Image. So you're going to have a training data which will contain all the information that you need. And then based out of this training data, you're going to clean it up, make it in the shape that it needs to be. And then you're then going to use it to train a model. What is it? So remember I told you that you have this model, y is equal to mx plus c. Why I told you that y is the independent variable, x is the independent variable, y is the dependent variable. You want to predict y, right? So in this case, I want to predict someone's age, right? I'm going to say, help me find what m is and what c is. These are the things I don't know. I don't know what c is, I don't know what m is. Help me find what they should be in order for me to predict what someone's age is. What should my independent variable be? It could be somebody's height. It could be somebody's weight. It could be your race, something like that. These are all independent variables. So if I have this independent variable and find what M is and what C is, I'm able to predict what your age is if I've not seen you before. But I'm going to find it using Y that I already have in my training data. So this Y that I have here is going to come from my training data. So I'm going to go about and collect all this information from people that I know. I know their age, I know their weight, I know their height, I know their race. I'll collect all this information from them. And I will give it to this model. Y is equal to mx plus c. It's a linear model. It's a linear algorithm, I mean. And with it, once I find what m is and c is, in that case, my model is then going to be y is equal to maybe 2x plus 10. This one is my algorithm. Just see it as my recipe. This one is the model that I've created to predict age. This is my model. Whenever I get somebody new, I will then tell the person, give me what your height, give me your weight, give me your race. I will tell you what your age is. This is what we call inference. Because you've found out what these weights are, you're then able to call for something that you've not seen before. That is learning how to predict age using all these independent variables. That is classical machine learning. If you go to the large language model, which we are all using right now, it is a subset of the machine learning, which means you're also going to start from training data. Also, starting from training data contains all the information you need. But you're going to use a particular type of model, which is a deep neural network and a generative model like a transformer, right? And then you're going to use this big training data. Here, the data can be small, right? But here, this is training with big data. You're going to use massive amount of data to then train your model, that neural network model, or transformer model. And then you're going to create a model. Remember, this model then means that you know all the parameters, you've identified all the parameters. And then based on this model that you've trained, you can then start asking this question. Your scoring data is nothing but your prompt. That is your new information you're bringing, the prompt. You're telling it, help me find out whether I am compliant or not. As Sean mentioned, of the friend that you just want. Help me know whether I'm compliant or not. And this prompt goes into this pretend model, and based on this pretend model, it can then give you a response. You're not compliant or you're compliant. But sometimes the information in this pretend model is not enough to tell you whether you're compliant or not, because it doesn't know you at the time you were trained. It doesn't know what compliance means to you. So what Cheryl's friends do, he will tell the model that this is the information you should look at to say whether I am compliant or not. Maybe go look at this document that we have in our office and use that to find out whether we're compliant or not. That is the new thing that you're doing in machine learning, the generative AI. Sometimes this information that you have is not is too large that you cannot get into your model. What do? You can go retrain this model by giving it the actual data. To say, I want to fine-tune you so that you now understand this, my data. So I don't always have to give it to you whenever I'm training. I'm just fine-tuning you with my own data so that you can then respond when I ask you the question. In that case, I will have another version of my model, which is fine-tuned with my own data, so that when I then ask the model, am I compliant or not, it will just give me my response without me having to give it my actual data, because I've already trained it with my data. This is behind the scene what the AI implementation pattern can see. If you are coming from the classical model, right, which is using small data, not very large amount of data, you can do all these kind of activities. All these things that you're seeing here are the different algorithms that you have. The algorithm that I mentioned, that when you're done with this algorithm, you create a model. These are the different algorithms you have. What you need to do is to bring in your data, right? So this is coming from scikit-learn. Start with your data. If your data is very small, go get more data, right? If it's big, what kind of thing do you want to do? Do you want to find out a class, or you want to predict a number? If you want to find out a class, these are the kind of things you should do: classification or clustering. If you want to predict a number, maybe predict somebody's wage, then you should go do regression, right? Or dimensional reduction. These are classical ones that people do, and it is very, very important today, even though people don't talk about it, but it's been in existence. Right? Anybody doing machine learning in the bank today is doing one of these things, right? So, which is super, super important too. If you are doing the other part, which is the deep neural network, it means you're going to have something that looks like this as your algorithm. You're going to use neural network. This video you're seeing here is more like a representation of how the brain works, right? So imagine right now that you have a kid and you're teaching your kid what a dog looks like. You're showing your kid both pictures of dogs, and then your kids pictures of dog in there. He or she is watching television and seeing dogs. a couple of things are recorded in the child's brain, in the neuron in the child's brain, to represent this dog. When you then go outside with this your child, and the child sees a dog, a real live dog, the child now says, "Dad, this is a dog." But you never told the child that this is that new thing that he's seeing is a dog. All he's doing is recollecting the information that you've already shown him, which is supervised learning. You've shown this child that anything that looks like this is a dog. It has created a representation of it in the brain, and is able to tell you when it sees a real dog that this is actually a dog. The same thing applies in neural network. You're having neurons of this nature, a representation, just a miniature representation of the human brain. So when I give you this image, I want you to say that this is a 9. When I give you this image, it is a 9. I will give you different shades of this image, right? It is written in different ways, but it is a 9. When I give you another 9 that is different, that is like this, or maybe termed in a different way, it's able to say that this is a 9 because I've shown it. But one interesting thing you should note about this is that whatever is coming into this, even though I'm showing you the picture of a 9, it is actually nothing but ones and zeros, zeros and ones. I am not giving it this image of 9. So when you go about and you write, tell me whether I'm compliant or not, yes, you're speaking English, but behind the scene is numbers that will go into the solution. It is never that will go into the neural network. But you see that this contains a couple of things here. These are all called hidden layers. This is what the model uses to learn. All this interconnection you're saying here, just like the way your brain is interconnected. That's what you use it to learn. If you are looking at this kind of looks like a matrix. So if you've ever worked if you've been in mathematics, you know matrices are like a lot of rows and columns. These are matrices of weights. These weights are really what represents the knowledge. So as I'm passing this information into this neural network, of course, the very first time I will pass this information, it will make mistakes. It will say, this number is a 0. And I will tell it, no, this is not a 0. This is a 1. This is a 9. And I will penalize it for making this mistake. And so it will send back the error and adjust this weight as it's sending back the error. Adjust this weight. And it's adjusting this weight in such a way that it will reduce the error that it is making, right? So that when it sends this, I send this number again, it will get close to 9. Maybe it will say it is 6. The next time, I will say penalize it until it keeps doing this until it says that this is a 9. I will say, yeah, this is good. Do not make any change to your weight. The weight you have now is good to predict this. And then we'll keep doing this. This now shows you that imagine you're going to do this for massive amount of data. You're going to be using your CPU for it. This could take years and millions of years, because imagine the kind of investigation you need to do. It could take millions of years for you to investigate this. And that is where scientists who worked with NVIDIA decided to use the graphical card. They actually noticed that the graphical card could be used for computing, and decided to use the graphical card to run parallel computing. So I can actually send all this information at once, adjust all this weight at once without having to go through them one after the other. That is where your GPU comes in to say, send this information together and process it in parallel. Adjust these weights in parallel and keep doing this thing. This is the standard thing that happens in any machine learning. This is really why we're using GPUs. And what will make you use GPU is a programming framework called CUDA. CUDA was developed by in NVIDIA, and which I believe Shem was trying to say one of the chip companies that is whose valuation is really getting over the moon. Right? They developed CUDA to allow you to use your graphics. So this the monitor you're looking at being used as a compute. Right? You're very used to using your CPU as a computer, but imagine using a graphic card to run things in parallel. That is what is used for machine learning. So I won't speak much to this, but this is getting all your images, your texts, your speech, your data, whatever it is, and using it to train your foundational model. And then when you train this model, you can then adapt it for question and answering. So you're doing ChatGPT. It is your foundational model adapted for question and answering. That is really why you can then start with it, right? Or you can also use it for other things, depending on how it is adapted. So some of them are adapted for code generation. So you're using something to generate code or to build your infrastructure as code and the rest. That is a foundation model that has been adapted for code generation, right? And things of that nature, which is the general way that we develop things. So if you're thinking about how can you create a solution, it's more like getting the kind of data you have, training your model, adapting it for what you want to use it for. I mentioned earlier that everything you're doing is math. It is numbers. In AI, it is a fanciful name of calling statistics. It's nothing but statistics and matrix multiplication that is happening behind the scene. Probability, that is all that is happening, but it's called AI in this case. So you bring your data, your large language model, whatever question you need to ask it. This question, you're typing it, but behind the scene, it is converted to numbers. So these numbers are not meaningless numbers. They're numbers that have meaning in them. It is what you call embedding, right? Say, I'm typing something, but behind the scene, it is converting it to numbers. When it converts it to numbers, these numbers actually have meaning. So things that have the same meaning, the numbers are close together. How do you measure closeness? You're measuring closeness by the angle between those numbers. So if the angle between those numbers is very large, then the numbers have different meaning. If the angle between those numbers are very close, then the numbers have similar meaning. That is how embedding works. If I have something that is here, this angle is smaller, but I have another one here, then it means these two vectors that I have here are similar. Imagine I have another one here. It means that they're very dissimilar. So the numbers are not just any number, and the numbers mean something. So imagine this scenario where you're then saying, help me, what is the capital of France, right? That statement is going to be converted to numbers. And that statement, what is the capital of France, will be mapped to something that is very close to Paris, because Paris is also a number. And it will be mapped to it, and it will say, what number should I predict as the next thing? It will say Paris, because in that vector space, this has been mapped close to Paris, right? Which is really what is going on behind the scene. So for you, this AI is super intelligent. What it's doing is guessing the next word, right? It is, yes, intelligent because it's been trained, but what it's actually doing is we're giving it a set of words, it is predicting what the next one should be, and it will send back that next one, predict the next one, and it keeps doing that. But you're seeing it as if it's typing and typing, but at the essence, it is just predicting the next word, the next token, the next word, the next, and until it writes the whole thing for you, right? So, which is why it will always tell you, do not trust what I'm saying, because at the end of the day, you should review it and validate that it's really doing the right thing. So how is this going to really work? So let me say, in a case for you, you really want to build an AI model. What is this going to do? You type this, your word. I will just use a part of this to represent what is going on behind the scene. What is the color of this cat? And this is the cat. You expect that this AI will look at this cat and say that, well, the color is white and brown, or something of that nature. How is it going to do that from the mathematical space? Because everything here is mathematics. How is it going to do that? It is going to convert this, what is the color of this cat, to the text embedding, which is a numeric representation of what you have. It is going to convert this, your image, to a visual embedding, which is a numeric representation of this, your image. And then it is going to do what you call self-attention, which is where your transformer coming. So imagine that what you have here, what is the color of the cat, is represented by this number 1, 2, 3, right? Inside this 4 until 9. Let me assume that this is the 9. This is for what I'm representing what at 1, is I'm representing it at 2, there I'm representing it at 3, at I'm representing it at 4. Just imagine that this is how I'm representing it. But this is just a numeric one. I'm simplifying the whole thing. When I convert it to this text embedding, what this layer is going to do is to help me adjust this my representation, right? It's possible that this thing I said here is pointing to somewhere here in the embedding space. By the time I consider the relationship between what is the color of the cat, I consider the relationship between them, I might actually be pushing this vector, adjusting this vector in such a way that I'm pushing it towards the color area of my dimension space. So here it is just a representation of what I typed here, but now I'm adjusting this weight based on the relationship I'm seeing here towards the color section of my graph. What is the color of this? Then this one, I'm also embedding it, and it is going to be, I'm adjusting it, by the time it's going through this, I'm adjusting it towards the white color side of my embedding space. At the end of the day, it will come out and tell me that the color of your cat is white. Maybe it's closer to white and brown. And then it will tell me it is a mixture of white and brown. You could then imagine what is going on behind the scene at the end of the day through this process of self-attention to adjust this. But everything here is matrix multiplication, right? The first time it will go through this, it might say that the color is black. And then you then say, no, it is not black, right? It is white and gray. And it corrects itself, and it will keep adjusting all these weights. These are all the weights that are part of the neural network model. The first time it will do it, it will just give a random weight. And as you're training it, it will keep adjusting this weight until it starts telling you the right thing, which is what you then say you've trained this model. Right? So this is primarily what goes behind the scene for training. I hope I'm not being very technical in the way that I'm approaching this. I hope you're getting the how am I doing on time? I know I'm almost at 4.
Good, sir. Good, sir.
I'm good. Okay. So that is like the science behind what is going on behind the scene. And I believe with this, you could see, why do we use GPU? Why do we need a lot of data? Why does this thing understand what we're saying, right? And seems to be smart, but which in the real sense is kind of just predicting the next word that is going on behind the scene, which is why you should always trust it and not accept everything you put by a thinker. But if you look at, I don't know where I have this on my screen, right? Maybe, I don't know why.
Yeah, I think someone wrote on the screen by mistake. Let me see if I can remove it from here. Apologies about that, sir.
Yeah, it's fine. I just wanted to be sure I'm not the one that
oh no, it's
let me go back to my presentation.
It's a virtual embedding.
Virtual embedding, yes. Okay, so let's then see. I also try to adapt this to say, even if you're not doing the AI part, right, the building the models yourself, right, it doesn't mean that you don't have a place to play here. The answer is absolutely no. What typically happens in this model, the difference between the way you build your software and you get to deploy it. I know you mentioned a whole lot about Kubernetes and all the beautiful things about Kubernetes. Somebody builds a software, deploys it, containerizes it, and then deploys it on Kubernetes. And the thing can scale as much as he wants, right? But most of the time, if in application development, people will always request for new features, and you then go ahead and create those new features, and then you keep deploying it in your DevOps process. But in machine learning, it is different. Because machine learning models are trained to learn from data. Unlike if you're building softwares, right? You know that if your account balance should never be a guesswork. It's either it is ₦1 or it is not. Like it can't be any other thing. It must be a particular number. If it's not that number, then it's wrong, right? So it is very cool to say I've developed this software and it's working and it's working. It's a core banking application, it's working. I don't need to do any other thing. I just need to ensure that when people are using it, it's working for them. But in AI, it's very different. Given that what you're doing is that you're learning from data. You can never learn everything. If you learn everything, then it means that it's called overfitting. You've actually fitted it much to the data that it actually did not learn anything, right? So because you're training with data, there is always a room for error that you should leave. It mustn't be 100% accurate. So that room for error means that you should always keep an eye on it. You cannot just say, I've deployed this model and you go to sleep. You must always monitor it. Why should you monitor it? You're monitoring it because the data that you used in training it, which is what happened in the past, right? It's actually a representation of what happened in the past, but it doesn't mean that that is what will exactly happen in the future. So in the future, you're generating new data sets, which might be different from the one that was used in the past. And so the model that you trained that learned the behavior in the past might not generalize the current behavior. And so you should always keep an eye on this model to say, are you still performing well or are you degrading? And you should also keep an eye on the data to say, is this my data still close to what I used to train it, or has it deviated a whole lot? These processes should kick off a retraining of the model. So it's like a human being that you keep teaching and teaching and teaching as the person is growing. So I taught my kid today that this is a goat, but this goat, the color is white. And then tomorrow my kid sees a goat that is black and said that this is not a goat. And I'm going to correct my kid to say, yes, no, this is, you're wrong. This is actually a goat, but the color is black. So you should also know that the color of the goat is not only white. Sometimes it can be black, or sometimes it can be a mixture of black and white. And that is the new learning that my child is going to get, so that tomorrow when he or she sees another goat that is now green, you now come back and tell me this is a green goat. And I say, no, the goat cannot be green. There is something wrong. So there is always a process of retraining as your data change, which is where you as a DevOps will always come in to like go through this process of retraining your model when you build it. So you're going to build the model, hide it, Kubernetes, of course, build it, put it in your container, deploy it. It's all running on Kubernetes because you have to scale as people are using it, right? And then, but you have to also monitor it. So where are you going to come in? The person that is going to build this model, which is the data engineer or data scientist, will obviously write the code to train the model. And when it's done training the model, it has to deploy the model. But you, the DevOps engineer, will be the one to create the MLOps pipeline. The pipeline for training the model, the pipeline for deploying the model, the pipeline for monitoring the model. You will be the one responsible for it. The data science engineer is going to train this model in a particular infrastructure. You will also be the one to set up the infrastructure as code, to be deployed. So this will be handled. The ML engineer, which I believe is I'll call it your DevOps person, will do more of this. Your infrastructure DevOps person will also do the infrastructure team, will also deploy the code. So that whenever you need this to be reproducible, whenever you want to work on this project, you already can deploy an infrastructure that contains all the libraries you need for the training. And all the activities that need to happen when you deploy the pipeline, you have the right infrastructure that you can run. How do you then go about it from a DevOps environment? How do you then go about doing it? You always have an engineer, a data scientist, the person that wants to try out some new ideas. come, you will most likely not start with all the data that you have in your environment because it might be very large and it's not good for you to start with very large amount of data. So you always take a subset of the data. You really will not train your machine learning model with all your data. So imagine this scenario that I come to this workshop and I'm telling you, tell me your date of birth. Everybody in this tell me your date of birth. And then when you all tell me your date of birth, I will then tell you, okay, this is your age. I built a machine learning model and it's telling it can accurately predict all our age. The answer is I did not do anything. I'm just regurgitating what people told me. In machine learning, you always take a subset of the people, right? A representative subset of the people. Go train a model. So I'll take a random sample of people here, maybe like 10% of the people here, and I'll use them to go train a model. When I train the model, I kind of see some good results. This model looks good. I will then go and create my training pipeline and then go to my dev environment, right? In my dev environment, I will have all my training data. So I use only 10% of my training data. Here, I'm going to use all my training data, 100% of my training data. But this 100% of my training data is not all my data. This is always less than 70% of my total data that is available. I will keep the remaining 30% to validate whether my model is working or not. I'll use all my data with the training pipeline that I've created to then run it against my dev environment. When I run it, I've created a model, right? I will use the remaining 30% to then test this model, whether it is working. So I've created this model and I'm using this remaining shadow data, that is like my shadow data for testing to test whether this is working. It's kind of a shadow of your crowd data. And you test it and you say, okay, this is good. Fine. I've validated that it's good. I then deploy it in my production environment. And then it goes to my production environment. And I start that process of monitoring it. The compliance officer will monitor the whole thing. And then if something is wrong, I'll kick off this process again of retraining the model with new data. So this is really how you'll be working with it and how you're also going to contribute to this process. So it is AI, but it is behind the scenes, a whole lot of teams working together. So what you do in application development is the same thing that we still do in machine learning training. Very important, the kind of infrastructure they're going to use for your training and inference. From a data standpoint, you typically use data lakes, right? Because data lake will store both structured and unstructured data. So if you're doing something like large language model training, you need data lakes. But if you're doing something like churn model and things of that nature, which requires structured data, you most likely use your relational database. You also see people using a lot of vector databases. I mentioned earlier that everything that you're doing in large language model, they are numbers, right? So the numbers are called vectors. So you have databases that are specially designed for storing those kind of numbers, and which you call your vector database, right? It will be designed, it will be used to tell numbers. So one of the points that Sean made was his friend created something that was able to tell whether he's compliant or not. But behind the scene, it would have given information about his data, and that data would have been stored in a vector database. It would have been indexed and stored in a vector database, so that when he's asking any question, he can easily go pick out what portion of that data will help give him the right answer that he needs. Right. NoSQL databases are also very, very important. And if you've used ChatGPT before, behind the scene is using the NoSQL database called Cosmos DB, right? Serving millions of people in the world for inferencing. For your compute, you can use central processing units, CPUs. If you're working with small data, like it's not all companies that have GPU. So you won't go to your company and say, you have to start training, like, go buy GPU for me. No, you can always start with your CPU for small data. You can scale up to GPU, right? For very large data. If you're doing anything large language models, you obviously use GPU. Remember, I showed you that matrix of weights, right? For you to be able to adjust them in a very efficient way, in a very fast and efficient way, you have to use GPUs. Does it mean you can't use CPUs? The answer is no. You can actually use CPU, but it will be a lot slower. Those numbers are more like they are called matrices, but they could also be called tensors, right? So you also have this. You came from Google, tensor processing unit. So GPUs and TPUs are things that are typically used to train all these models. And for you to use your GPU to work, you need the complete unified design architecture. This is like a framework to use your graphic cards to compute, right? And when you're done training this model, you can deploy it. So there are different frameworks for training your model, but you can deploy it with what you call your open neural network system. That means whatever framework you use, either you use TensorFlow, right, or you use PyTorch, or you use any of the libraries that are used for training, they can actually, and I want to deploy it on my mobile device, on my laptop, I will need to convert it to like an honest model, which can run on all these devices. So this honest model came from Microsoft and Facebook. They came together to work on this. I think you have this different framework for training. I will switch fast because I know my time is fast spent on where we are currently going in AI, which is really where I want you to focus on going forward. If you really want to follow the trend, I'll kind of quickly switch to what I see that is happening, especially given that you guys are DevOps engineers. New applications that will be built over the next 24 months, 1 billion. Like how many applications do you think they are building right now? If you're going to be building 1 billion within the next 2-3 years, then it means each and every one of us will become software developers for us to contribute to this 1 billion. And 90% of developers are using AI tools. So if you're here and you're not using AI tool, you are like among the 10% that are not that will be left behind, right? So this just shows that there's just a whole lot of adoption in AI. But what are people doing, right? I will quickly just talk about what the main thing that people are doing. They're doing a lot of agentic AI, right? You've used ChatGPT, you've used Copilot a whole lot, but things are then moving away from being this question and answering UI to actually doing things, actually acting on your behalf, doing things. That's really the agentic AI space, right? And 2025 is really the year of agentic AI. This is what is really moving the market right now, where AI is not just interacting with you, it can actually perform actions, right? And so when you have your MCPs that are connected to your APIs, you can actually use them to execute things, right? You have your MCP for even the MCP that will help you create your infrastructure as code, right? So you're working right now, you need something like GitHub Copilot to help you build your infrastructure as code. There's an MCP that will help you do that. There's an MCP that will help you write your code. There's an MCP that will help you do unit testing. These are all allowing your AI to connect to your existing tools, right? And which is really where the agentic AI is going to. So this is really where, and to the point that you mentioned around somebody trying to use the AI to actually know when he or she is not compliant. This is really acting. Like if I'm not compliant, maybe do something. Like what from an agentic standpoint is if I'm not compliant, I need you to send me a Teams message to say you're not compliant. I need you to act, right? Or perform something to make me compliant. This is really where we're going. From a responsible AI standpoint, there are key things that you should always have in mind. This is actually a Microsoft AI principle, but it's being adopted everywhere. When you build AI, or when you also adjust this AI to work for you, you must always note, right, that you are accountable for AI. Whatever thing this thing does, it is your responsibility. So don't say, well, it was done by AI. The truth is you are the one responsible for it. So you are accountable for everything that this solution does. And you should always go for transparency. It is not enough to say that imagine this solution that you created the solution to tell you whether somebody will will churn or not, whether somebody will default on the loan or not. And behind the scene, the data that you use to train it showed that all the females in this data set defaulted. And so what the model actually learned was to say that once you're a female, then you will default on the loan. How will you know this? Is by being transparent on the model. The model should tell you, why am I doing this? What am I doing? Why am I doing what I'm doing? And if it doesn't know, it will always tell you, right, this is AI. Please do not trust me. Review whatever thing I've done. That is where the transparency comes. When you're seeing AI put up all those things, if you're chatting and it's telling you this is generated by AI, you should always look at it. It's coming from this principle for responsible AI. It should be transparent, right? You should not just talk and say it is my work when it actually came out from AI. It should be fair. Fairness means treat everybody. Imagine you're collecting data to train, and everybody is depending on this data. And I'm collecting it only from the global north. I'm collecting it from the US, from the UK, but I'm not collecting anyone from Africa. But I expect this model to be used all the way, like in Africa, we're using it for everything. So in fairness, I will actually put this one inclusivity, but it could also speak to fairness. Making sure that everybody is included in whatever you're doing, or putting everyone's work. And then reliability, privacy, these are all, if you're training with people's data, you should always make sure that you respect people's privacy. AI will always come up with a whole lot of new risks that are applicable in the industry. So when your data is biased, it's a risk. When it is skewed against people, it's biased or skewed, it is a risk. When you cannot really interpret what this AI is doing, but you're using it to do your work, it's another risk. When there's really unfairness from the model, from the algorithm itself that you were using in training it, it is also a risk. When it's giving you, I believe you've used ChatGPT or Copilot, and sometimes you're seeing some results that you don't really understand. Like, where is this thing coming from, right? Giving you ungrounded outputs or error. Of course, it's just predicting the network, and so it could actually give you things that are not correct, right? People can also deceive it, right? Jailbreak or prompt injection attack, or it could also generate harmful content. There's nothing that says it shouldn't generate things that are harmful, or there are maybe things that are not maybe sexual content or things of that nature, which could impact your image, right? As a content, so it could actually generate it. And remember, it was trained with a lot of information, so you could actually generate content that are seen as proprietary, right? So I created this document, and it's my own work. I have the patent for this work, but it could also go generate it because it could have seen it in the training data. So, which I told you that you are accountable for it. If you use that work, I'm not seeing the AI, I'm seeing you for bridging my patents. Right? So these are some of the things some of the risks that you're seeing that will come from AI. And so they will always, if you're going to be developing AI yourself, find the right team for whatever use case you have, between whatever potential hole will exist in your use case, and try to red team it. Find out whether this will cause any risk, and then measure, mitigate, and then keep on this process. So this is really what then goes in from an MLOps standpoint for anything that has to do with large language model. The red team will always find how are people trying to use this to cause nuisance or to cause harm or to cause harm. They measure the impact, mitigate it, and then put it into operation. That's why you're seeing, as you're using this model, it keeps getting better every day, and people are adding a lot of features. What mitigation areas are you going to look at? It's more like mitigation layer that is in loop, like inner loops of you have the model itself, you must choose the right model, you must put safety around this model, and you must also give your system message to ground the information to make sure that this thing is always doing what you want it to do. And you must also design your user experience in such a way that people are responsibly using the solution. going forward. I would like to stop here because I kind of feel like I've gone way into beyond the time that is allocated to me. Right? I believe that is the case because I know there is time for questions. So, but let me stop here and let's get your questions if you have them.
All right, thank you so much. I mean, this is just awesome. I mean, from just going to the basics and showing us, we've seen a lot of things behind just the prompt. I mean, how it's just beyond the prompt. And I mean, taking us back to y is equal to ms plus c. And truly, like you have said, everything about computer, everything about AI is numbers, zeros and ones. No matter how complex you are seeing in front of you, behind it is all zeros and ones. If you're just putting it together. Okay. What to just have a 10 minutes round table, just to have a deep dive into the discussion. That will involve the speaker for today and the founder, the co-founders, the three co-founders, just to talk more around we want to get deeper insight around behind the curtain of AI. And so, well, opening the floor for Dapo and Nuruddin. Nuruddin, are you there?
Yes, I'm
Because of
here.
our time, we just take one question, just to get a deeper insight around what happens behind AI. So I will start with Dapo. Dapo, over to you.
All right. Thank you so much, Doctor. Thank you so much for this very explosive presentation. In fact, actually have 5 questions, but since the moderator had actually told us to, ask just one question, I would, I want to ask 2 questions. I don't know, Sheon, if I'm permitted to do so, but it's going to be very quick.
All right,
Yeah.
2 questions, no problem.
Yeah, cool. Now, predicting the future, right, Doctor? What do you think is the next big thing to come out of this space, right? So you mentioned agentic AI, which, of course, like this is the new frontier that most organizations are, working on. But aside from agentic AI, what do you think, in your opinion, is like the next big thing to come out of this space, right? Something that nobody would ever expect, the same way we had Gen AI, right? So that's the first one. Then the second one is for people that are just starting out, because within this bootcamp, we have like so many people that are just starting out in the AI space. So many of them want to integrate their systems with AI, right? And um, people that actually want to start out, for example, in MLOps, machine learning operation and all, within an organization that has data, right? Organization that has like a lot of data. Is there a pathway for someone that wants to start out in MLOps? Like, is there a pathway that person can actually take? Because you're working in an organization and you have been informed that, say, look, we have a lot of data. We need to be able to intelligently work with this data, because data is just sitting down there, somewhere like in a data store. We need you to, bring out the best out of this data. How do you now intelligently, retrieve, data from all of the large data sets we have? So someone that is just starting out, what do you think is the pathway to take? So those are just the 2 questions I have. Yeah.
Okay. So the very first one on what is the big thing, right, that will come out of AI? To say that I know what exactly is going to be, I will be lying, right, to you, because this space is really evolving very well. But I will speak from my own point of view on what I see is the limitation of AI today and what will make it very, very powerful in the future, right? Everything I've explained to you about AI um, is actually very, very domain specific, right? As human beings today, um, you can switch from being a father to being the best coach of Nigerian football in the next maybe in the next 12 hours, 24 hours when we're playing DRC. And you're doing all this, switching context and like having very full coverage of whatever domain that you're working with, but maintaining a lot of your context window is very, very massive. Since you were born up till now, that has shaped what you're doing. In AI today, there is always that limited context we have in AI. And the AI that we have is always focused on something, one thing and doing it well. So when you see we're moving towards the era of agentic AI, it is about trying to make AI do one specific thing and do it well, right? Around that space, because that is where AI will do well. Unlike human beings that we can do well in multiple things, like we have a whole lot. So that part of moving towards the artificial general intelligence, which is making AI perform very well across multiple domains, right? And having a lot of context that it can be easily confused, right? As it's switching from one context to another is what is really going to change. It's really going to change AI. And that is why you're seeing everyone working towards creating this AGI inputs, right? Because that is something that the computer, even though, no matter how smart it is right now, the models we have can't do it. So that is one thing I know that will really transform a lot of what we're doing to have a single model that is super, super, super intelligent, right? In the real sense, it's not intelligent. The models we have here are not very, very intelligent in quotes, but just being able to predict things. On the second question of where do you start, I would say there is this tool that I have here, the AI Skill Navigator, which you can use to personalize your learning, right? Because you all have our comments on Microsoft. This tool is coming from Microsoft, right? You can use it to personalize your learning. Okay, this is what I want to achieve. I'm an executive, I'm a developer, I'm an IT professional, wherever space you can say, I want to learn about AI, right? And then you obviously have to like sign in, and then you then have more like a bot that will guide you through how you can personalize your learning, right? To say this is your skill level, this is what you want to do. You can go through it in this way to say, what are your learning preferences? What roles do you have? And by the time you put all this information, you can then start your skill. And it will then curate learning materials for you to then use to do what you want to do. The AI Skill Navigator is the tool, is what I'm sending everybody to use and learn. And the other one, that's if you want to, that's your learning the basics. The other one is you're already using these tools, Copilot. You're using Copilot. If you're using Copilot or using something like Fabric, these are tools, AI tools that will do massive analysis for you. So you say you have a lot of data and you want to go analyze it. There are different copilots that will do the analysis for you. So you have your data analyst as an agent, or you have your Microsoft Fabric, which will look at your data and analyze it for you automatically, without you having to do the analysis yourself. So end users use the Copilot agent. For people that want to really know what's going on behind the scenes, use the AI Skill Navigator to scale yourself up.
Thank you, sir. Well answered.
You're welcome.
Yeah.
You're welcome.
All right, thank you very much. Move over to Nuruddin. Nuruddin, your question.
Yeah, thank you, Oluwaseun, and thank you, Doctor, for the good session. I think you've been able to, talk about, what is going on behind the scene, trying to break things down as much as possible. I really appreciate that. However, I have quite a few questions I would like to ask, but I will just basically, take 3 of the questions if possible. And the first question also has to do with, the AI ops, especially from the infrastructure and operation side. And as you can see right now, people have been using, AI for, for triage, especially in the operation side, trying to use it to monitor infrastructure incidents, and also respond to incidents and stuff like that. So my question is, what do you think are the limitations that engineers should be aware of when it comes to, relying heavily on AI for, for triage? That's the first question. The second question has to do with security concerns, because everybody is developing AI powered system, integrating AI into their cloud environment and stuff like that, right? So what are the security concerns you think people should be aware of when it comes to putting AI into their environment, especially regarding data privacy, secret exposure, model poisoning, and stuff like that? And my third question also has to do with the mentality of people, right? And the mentality of people is that right now, considering the fact that even organizations, they advise you to use AI, tools to code and stuff like that, right? Do you think that the fact that there is high dependency of Copilot, course for AI and stuff like that for coding is going to make it easy for people to easily transfer or diversify into software engineering, and what is going to be the impact on the knowledge that new people that want to move into software engineering, what is going to be the impact on them? Then at the same time, in regards to this, when we also talk about this, do you think it's advisable for people to learn prompt engineering when it comes to AI, so that they can be able to relate perfectly with AI? So I think these are just my three questions.
Yeah, these are very, very loaded questions. So let me go to the first one about the AI triage, right? Especially from a monitoring standpoint, and what the limitations of AI is for when you're performing trial. Something that you ever want to take away from this discussion about the limitations of AI is that your context really matters, right? So when you're performing triage, right, AI can only produce as much as you give it. So I have this VM that I'm generating telemetry from this VM, and I'm then using this VM to monitor traffic. I'm using this telemetry to monitor traffic. Everything that AI is going to tell you is going to be based on the insight that is coming out from this telemetry. But that is the only context that it has. So you should always know, as an infra person, that it is giving you information based on the context. It doesn't necessarily mean that that is the right thing, or that is a representation of what is going on behind the scene. So I will answer a bit of prompt engineering in this response. Much of what you as an AI user should be concerned about is what context are you giving to your AI model. So that context will determine how relevant whatever this AI solution is doing is to you. So imagine this scenario that there is like maybe something that was released by CBN to say like everybody should stop using this service, and then everybody just stops using the service, and then it's reporting to you, or maybe sorry, something was released and it's saying everybody should use the service, and then you're seeing your VMs get like 100% utilization all of a sudden, and services are shutting down. The model will tell you obviously that something is wrong, but it doesn't have the context that there was something that was released by CBN, and based on that, these activities are happening. And so you're running helter-skelter based on something you have the context of everything, but AI doesn't have the context. It is only going to respond to you based on whatever context you're giving it. So note that you have to be sure that the context you're giving it is the correct context, and then just know that is the limitation that you have, especially when you're using it for triage. The other part is security concern. This one is super, super, super important. I don't know if I'm sharing my screen, am I?
Yes, you are. Yes, you are.
Okay. So I would like to explain this. So I didn't go much into the security. I didn't say everything I needed to say for the security part, but I need to just highlight the second part. When in the industry, in your enterprise now, you're going to be sending in data, and you know very well that whatever you send to AI is going to reason over it and give you a response back. However, it might, for you, it might mean nothing that I'm copying this information, I'm sending it to AI. I'm pointing the AI to look at this file. But from a security standpoint, you're breaching the security and compliance rules, which you might not know, right? So maybe you're using this thing and you really do not know. And so it makes sense, right, that before you even go into using AI in the enterprise, you should first start from an application standpoint. What data should you allow your AI to see, right? I'm not here to sell any product, but there's this product here called Microsoft Purview, which is one solution that Microsoft have for data security, governance, and compliance, which you as an AI user, like anybody using AI, should activate to say, if I need my copilot, if I want my copilot to go look at my enterprise data, I need to be sure that it is seeing the data that me, as Nnanna, I'm supposed to see. So it is a representation of mine, so it's seeing the data that I can see. I'm not seeing all the data that I have in my enterprise. I also need it to be sure that it is not pushing personal information, right? And all this can be controlled using like your Microsoft Purview, or if you have any other tool that sit behind the scenes, ensure that people are compliantly using these tools and not exposing the enterprise or sending in their data to using solutions or using the Gen AI solution. The other one that you should also consider is the model that you're using. Does it have any safety system that is there? Right. So of course you're going to send your data, but does it have any safety system? Safety system of preventing you from sending in corrupt data. Corrupt data might be violent content, or you're sending in sexual content, you're sending in harmful content into it, blocking you first before it doesn't get to the model. Or also preventing it from generating all this content back to you. So another question you're supposed to ask is, this model I'm using, does it have any safety system that is there? In the case of most model you're going to see in Microsoft, it has this Azure AI content safety to ensure that I'm blocking you from poisoning the model or getting information that are going to be detrimental. And then the model itself, you should also ensure that you're using models for which the provider is also putting in model safety to ensure that this model is not poisoned with bad data. But if you want to poison the model with bad data, of course, it starts giving you harmful information. These are the things that you, as an organization, should always ensure that these compliance or monitoring solutions are there. And if people are using this, you should also monitor to say, what are people doing? Are people trying to jailbreak this? Are people trying to get content that are not right? You have a monitoring solution to tell you when things are not working well. And the last one that you mentioned, like, should people, for software developer, like should they know, should everyone become a developer, and even though they don't have the major skills, should you go about still learning how to develop because AI is there and can run whatever thing you want to run? I would say you still need to be a developer. You still need to know software, right? For you to tell AI, ask AI the right question, you obviously will understand what you're doing, right? So I want AI to develop an application for me. As a developer, I should be able to ask that it uses the right database and it uses the right, it deploys the application in such a way that I'm not going to break the bank, right? So I won't just, okay, go deploy this application. I know my company cannot write a wonderful application for me, and it writes this application and is deploying it on Kubernetes and is using ABC, everything like that. But in the real sense, I actually would have just deployed and used like maybe my storage, use my storage as a static app, right? You as a new developer might not know all these things that, well, everything mustn't be deployed on Kubernetes, right? Things can just be one static app that is on a storage that will not cost you anything. You don't need to deploy an app service to run it, right? Or it will take an experienced developer to know the kind of questions to ask and not just somebody typing anything. So do you need somebody to be a developer experienced one? Yes. Like for me, you still need very, very experienced folks. Will it support you as an experienced person to do work faster? Yes. So please do that route. But for the new guys, it will help you do your work, but it shouldn't take you away from the fundamentals. You have to know the fundamentals to be able to excel. Do you need to know prompt engineering? Yes, and yes. That one is very important. You should know how to ask questions. They call it prompt engineering, but I call it English. It's just English. You know how to ask the right questions, right? And I put it here, asking the right question with the right context. Always know that if you ask the right question without the right context, you still get the wrong response. And note, it is just predicting the next word. It is not God behind the scene that is super intelligent.
Yeah, thank you very much for that. That was very explanatory and well defined. So now I'm gonna open floor for the mentees to ask questions. I'm just gonna pick about maybe 3 to 4 people questions. I think there is already a question on the chat already. However, if you have or any question you want to ask, please try to just signify. I'm gonna call your name and you can unmute and I can, tell you to go on with your question. But for now, I will start with the first question that we have on this chat here. This is by Idris Alugo. He said, "Thank you, sir, for the talk for today's talk. I have noticed a lot of focus on development, security, and infrastructure, but not much around explainable AI. Given how important transparency is becoming for AI adoption, I would love to hear your view on where explainable AI fits into the future landscape." I don't know if you'd like to take that as.
Yeah, this is a very, very important point that was made. I can't remember the name of the person that asked the question, but it is super, super important. The part of the part of responsible AI that gets to speak to explain what is going on behind the scene can never be overemphasized, right? Because I will say this. Imagine you tell your bank manager that I want you to invest in this business because AI said you have 90% possibility of doubling your return on investment. It would be foolhardy of any CEO to take that, to do that. Foolhardy of any CEO. The CEO would obviously ask why did you say so? Like what is responsible for this prediction? Which is where the transparency coming. So why is this large language model telling us we should do ABC, right? What is responsible for it? Why we need to know what is going on behind the scene. That hasn't been solved. It is an open space that needs to be solved, right? Of explaining what is going on behind the scene. Unfortunately, no, it hasn't been solved. There are different things that people are doing to explain what is going on behind the scene, but it's really massive. And I agree with you. It is another area that really needs to receive a lot of focus to explaining why AI is doing what it's doing.
All right, thank you, sir. Idris, does that answer your question? I don't know if she's there.
Yes. Thank you, sir. Thank you, doctor.
Okay, thank you. Oluwaseun, I don't know if you also have some other questions you want to ask.
Okay, thank you very much. We're supposed to round up the roundtable discussion with the speaker. You talk so much around, when you were explaining the dilemma that can happen around, yes, in your mind, you are trying to explore use of generative AI. And there's a very thin line between your exploration and you breaching in an intellectual patent if you're not very careful. And so that will bring me to my question. What do you think industry should do to prepare for the ethical dilemmas that is going to be posed by autonomous AI systems in critical infrastructure?
Yeah. So it is also a very, very important point that you're raising, right? Around intellectual property. What should the industry do, or what is the industry doing? Because it's really an ongoing work. Industries already have solutions, right, that are there. I can say this because I work for Microsoft, and so there are tools already in Microsoft that is helping for this. But this tool that I mentioned here, which is really where tooling come into play to say, whatever thing that you're designing, look for tools that will help you identify this. They're already available to help you identify when you're creating or when you're bridging intellectual properties. Adopt those tools when you're developing or using AI. You might not, obviously you will not have the capability to build out your tools yourself, but for enterprises that have built their own tools, please do adopt those tools for what you want to do. If you also have the capability of building your own tools, right, also adopt the tools. So let me say, for instance, you're using this in your within your application, and you already know that there are some content that are proprietary that should never ever get out to the AI. You can also build your own filter to say anybody who is going to use this, you have to use this filter. I will filter out the data before it gets to the model. Right. So these are also another way that you can do yours, but please adopt industry tools like the Azure AI content that will help you automatically that will prevent you from sending in proprietary content and will also prevent the AI from generating proprietary content into as a response. That is at least a way to ensure that you are not breaching this. Because how will you find out what is proprietary? Right? There are tons of databases that host this information, and these companies have already trained another model, because it's also AI that will help you find out this. Has already trained another model to identify this proprietary content, so that when it receives yours, it does like this pattern match to say, is this proprietary or not? And if it flags it as proprietary, then it blocks it. Right. So you do use these tools.
All right, thank you very much, Doctor. We deeply appreciate. That brings us to the end of this roundtable discussion and questions from the audience. I would like to call on the boot campers to give a vote of thanks. I'm calling on Mayowa Lawa on behalf of DAS Nigeria and his fellow boot campers to give a vote of thanks to the speaker of today. Mayowa, are you there?
Yes, I'm there. Good afternoon, everyone. Good evening. Thank you, DAS, for this amazing opportunity. On the behalf of my fellow mentees at DevOps as a Service, it is my great privilege to extend heartfelt gratitude to our distinguished guest speaker, Dr. Nnanna Orieke. Thank you, sir. The promise of today's webinar was to show us how AI really works. You've truly delivered on the promise, and you've taken us behind the curtain. In a world where AI is like magic, you've not shown us that. You've shown us engineering. You've showed us the process. To everyone, we are leaving this session today with a clear vision and less intimidated by the buzz and more empowered by knowledge. Thank you for your time, your expertise, and for treating us as the next generation of engineers. To our founders and hosts, Mr. Oladapo Babalola, Mr. Oluwaseun, and Mr. Nuruddin, thank you for your vision. Thank you for creating this platform and for consistently bringing in industry leaders like Dr. Orieke to give us high-level and practical exposure. Dr. Orieke, thank you once again for an insightful and groundbreaking session. We are so grateful. Thank you so much. Thank you, Daz. Thank you, everyone.
Thank you, Mayowa. That was a lovely one from you. Thanks. So Dako will be taking the closer a recap point from Nuruddin. Nuruddin, please go ahead, just a recap of what we've seen so far.
Yeah,
Please, very, just a minute to just do that.
yeah, sure. I think for me, one thing is that when we wanted to start this today's presentation, maybe you or Dapo started with the fact that this is not just Kubernetes, right? And I like the fact that, Doctor was able to go behind the scene, right? It was able to start with the fact that, what is the concept of artificial intelligence, putting it down to, to the machine learning, going down to deep learning, going down to, generative AI, which was very good because it kind of give people like, a concept. Then it went into, the different, models or ways that people go about it, talking about, the classical model and the LLM, and most importantly talking about the importance of transformer, because the transformer is actually what makes it very easy for you to go with the new ways things are being done right now. And at the same time he also went into the ML ops of it, talking about the roles of the infrastructure engineer, the DevOps engineer, in helping to to build ML ops pipeline and making things very easy. And at the same time, I like the fact that you're also able to address different security concerns which was asked during the session. And you talked about the fact that security is important. It's also important for you to have like different guards. And I like the fact that throughout your one thing I like is that throughout the whole explanation you started with the concept of the equation of a line, right? And putting it from variables, independent and dependent variable, which kind of gives like a clear concept about the different things. So we really appreciate you, sir. Thank you so much, sir. And I believe that the mentees have been able to hold on to one or few things that they can work on and continue to build on accordingly. Thank you, sir. Dapo, over to you, Oluwaseun.
All right, thank you, Nuruddin. So I want to just appreciate guest speaker for today, Dr. Nnanna. I know how much of what this time is. I mean, to give 2 hours of your time to come and address this audience, we deeply appreciate. We take it not for granted. We are grateful. Thank you for the engineering touch. I always say that when engineers, when they speak, you always know. And from the way you started it, you know this person has an engineering background. We deeply appreciate, and the audience also. We thank you all. Weekend here in Lagos is is one that everybody wants to find one or two things to do. You want to find time to rest. You want to have different activities and programs that you want to join. We've all created this time, dedicated our time, I mean, to be part of this webinar. We appreciate you. On behalf of DAS Nigeria, we're saying thank you very much. And thank you very much, everyone. Thank you, Doctor. Thanks for coming and thanks for giving us this time. So I'll give that for the mic to go ahead to address us on our upcoming sessions and other information for the community.
I believe I can, right?
Sorry?
I believe
Over
I
to
can
you.
leave, right? I was saying I believe I can leave, right?
No, you can
Yes,
still
sir.
wait.
Okay.
We're actually running up in the next 1 minute. The next
1 minute.
Okay.
yeah, 1 minute. So once again, thank you so much, Sheon, for that wonderful moderation. Thank you, Nuruddin. So once again, I know there has been a lot of thank you. But once again, right, on behalf of the co-founders as well as the founder, we just want to say a very big thank you for this very explosive webinar. Doctor, to be honest, your presentation was very clear and easy to understand. And of course, this is the video that we would have to go back to watch over and over again because the mentees as well, they have to go back to their respective groups to sort of, dissect this video. They will have to watch it and then discuss all that they've learned. So once again, thank you so much, sir. And of course, personally, I have to go back to dust my college mathematics to learn more about algorithms and all. So thank you so much for honoring our invitation, sir. This was really an eye-opener presentation, and we'll look forward to seeing more of you within the bootcamp itself. All right. So to all our mentees, this video is going to be uploaded on our YouTube channel, and we would make it public so that anybody from everywhere can always rewatch the video as well. All right. So let's be reminded that our next class is on Saturday, right? And we are going to delve into GitOps to be taken by Nodin Camilo, right? So yeah, thank you so much, everyone. Thank you so much for joining. Once again, thank you so much, Doctor, for honoring our invitation. And we'll see you back in class. All right. Enjoy your weekend. Bye. Bye, sir.
All right. Bye, doctor. Thank you so
Yes, sir.
much. Bye, everyone.